variable values together within the same, they're all the industry dummies. And we can see that from those indicators, for every individual, if I sum up across the rows, across the columns, sorry, for the same role, then I would end up with the sum up of 1, 1, 1, 1 for each individual. Okay, so what's that imply? That basically imply that, remember, in our regression, we always throw a constant inside the regression. And a constant in the regression, how that enters the regression? A constant, C, inside the regression is the case that it generates, EViews will generate an internal variable for C that it insert the value of 1 for every individual observations. And if we compare this constant with the sum up cases of all of our industry dummy variables, we can find out that they are exactly the same, perfectly collinear. So this is where our collinearity coming from. So the only way that we could identify those dummy variables is by dropping one of them. So that is why, if you could remember your econometrics too, that you have to drop one of them. If you have n categories within the industry classification variable, then you can only throw in n-1 dummies inside into the regression. Okay, remember, so that is the collinearity issue. So in this case, as we said in our notes, that we want to drop which variable? Drop the individual who come from the manufacturing sector. Now, according to the value, that corresponds to the third value here. Okay, so we will drop the dummy, the third dummy here, that takes a value of 1 if that individual is coming from the manufacturing sector. Now, how do we drop that? If we throw in 9 dummies, then it's fine. But if we utilize, remember, the internal command called the expand. How do we tell EViews to drop in that specific one? So the trick is, again, I can still type in expand and end, but instead of finishing there, I would just add in a little bit extra element inside the bracket. So what I would type in is to introduce another built-in function called drop. So at drop, and then within the bracket, I will specify the value corresponding to that categorical variable that I want to drop. In this case, the value is equal to 3, remember? So I would fill in 3 into the drop bracket. And then, if I click OK, nothing reported wrong. Okay? So, you type in at expand bracket, say for example int, and then comma at drop, and then bracket. Inside you just put in the value corresponding to the category that you want to drop. In here, the third category is manufacturing sector. So you just drop in when that value is equal to 3. So then automatically you can see still it throws in all the dummy variables except for the dummy variable from the manufacturing sector. There will be no labels coming from the manufacturing sector. So what would be the interpretation? This would be, particularly once we drop one of the categorical variable. So the interpretation is we would basically take that dropping category as the reference category. So the interpretation on the coefficient for all the other dummies, for all the other subcategory dummies, would be that the marginal increment of likelihood of deciding to participate in the labor union relative to this is marginal increment, relative to the reference category. In this case, it's the individual who is coming from the manufacturing sector. So for example, here, I'm comparing the construction sector, for example, and the coefficient is minus 13. So my interpretation, remember in the linear probability model, is that this coefficient is directly the slope, directly the marginal probability. So that basically means given an individual who is coming from the construction sector, then given all the other things the same, compared with the reference or cohort individual who is coming from the manufacturing sector, then he will be 13% less likely to decide joining the trade union. Is that clear? So this 13% is the relative probability to the participation decision of the reference category individual. So that individual is coming from manufacturing sector. So the reference category, reference individual will be always the one that you drop the dummy. That category that you drop the dummy. So similarly, I could interpret it as the bank, the financial sector. You can see it's a negative, slightly negative, about 9%. So the interpretation would be compared with the cohort. So given a cohort coming from a bank sector, then compare this cohort with another individual who have exactly the same age, exactly the same gender, all the other things unchanged, but coming from the manufacturing sector, then this guy who comes from the banking sector would have 10% less likely to participate in the trade union. So it's always the comparative relative interpretation. Okay? So that is the trick of interpreting those categorical dummies. Okay? So similarly, we can do another exercise. So we have thrown in the individual categories. Then we follow on. We must throw in the qualification, the highest qualification, the certificate that they get, as well as the region that they are from. So as we said in the notes, that we want to, again, if you want to throw in, you can't throw in all the dummies, then you again facing the collinearity problems within the category. Again, so we drop in, within the region, we drop in people who come from the Scotland. So the Scottish people will be the reference category. But together with our combination of industries, then our reference individual would be a person who is Scottish and working at a manufacturing sector. And then, as long as we add in the higher allocation, we drop the degree. So the first degree, sorry, the high school degree, middle degree. So that would be an individual who is coming from Scotland, working in the manufacturing sector, who got a degree. So that would be our reference individual. So again, the way we modify our regression would be continue by specifying firstly the region and firstly the qualification that they have. So it is H4 in our variable, but again, drop which variable, drop which value. Remember here we got 5 categories in our sample, so we would drop the one with the degree. So it is the value of 1. So we'll just fill in the value of 1. And for the region value, we can see we have 11 regions. We want to drop the 11th value because that is the one who is from Scotland. So then, ultimately, I would modify our regression, drop the value HQ using 1, and then also add in the region variable, but drop the value of 11 because that is the category indicating the individuals from Scotland. So after we've done that, this is the result. So again, it will be constant, it will be age, it will be female, gender, and then followed by the qualification variables, and then industry variables, and lastly region variables, region indicators. Okay, so again, our interpretation, for example, we've done the individual one, then let's say, for example, about the region, and let's find out the Welsh. So South Welsh, sorry, Wales, here, the very last line here. So compared with the worker or individual who is coming from Wales and working in which industry? The reference industry, the average industry, which is the manufacturing industry, or given any industry, then the interpretation is that any individual who is from Wales, compared with a similar cohort with exactly the same age, exactly the same gender, exactly the same industry they're working in, exactly with the same level of degree, but compared with the cohort, just different in terms of the location, who is coming from Scotland, then a Welsh worker tends to be more likely to join in the labour union by about 4% here. Okay, so if we compare average people from Wales with our reference category, which is Scottish people, then given the same level of education, same working in the industry, same age, same gender, then this Welsh worker tend to be more likely to join in the labour union than the Scottish cohort. Okay? But of course, all the interpretation, again, are based on that coefficient, and also, I'm just assuming that this is statistically true. So before I interpret it in that way, I should check the statistical significance. Right? If statistically that is not significant, for example, this northwest dummy is not significant. What does that mean? That basically means compared with a pair of similar cohort, one is from northwest region, and the other is our reference category, who is from Scottish, then statistically, they are roughly the same likelihood. They have roughly the same likelihood of deciding to join in the labour union. Because this is statistically insignificant, although we got some positive number here. Okay, so remember, statistical significance really tells us that in the statistical sense, whether those coefficients do differ from 0 or not. So if it's significant, it means it is different from 0. Or it is different from our null hypothesis. Our null hypothesis is 0. Okay, so similarly about the Yorkshire people. Okay, so if I choose the 5% as a significant level, then compared with the cohort who working regardless of the region, just as two similar cohorts, and they may come from the same region, then the similar cohort who working in the other sector compared with the similar cohort who just from the manufacturing sector, then is less likely to join in the trade union by about 2%. This 2% tends to be statistically not quite significant. It's on the 5% margin. If you decide to adopt 10% as your significant level, then it is significant. But if you decide about 5%, then it's on the margin. If you decide about 1% significant level, then it is insignificant. Okay, so Usually we choose a 5% level. Okay, so clear about how to interpret those categorical dummies? And then we go back to the traditional issue. So for example, the female dummy, which is simple, that given all the other things the same, if this individual happens to be female, then compared with male, she is less likely to participate in the trade union by about 5%. Okay, that would be the interpretation. Again, bear in mind about the significance. Now, the tricky thing is how do we interpret the age effect? In this equation, we have two terms relative to age. And we can't simply just say, well, on average, if an individual given the same age, from the same industry, from the same region, with the same qualifications, then if we just follow that interpretation, would be saying that as long as the individual getting 1 year older, then he is more likely, he is more eager to participate in the labor union by about 1% of chances, or by about 2% of chances here. But we can't simply stop at that, because again we have a second term, which is the average thing. And if different individuals in our observation have different age, then we can see that the two, in combining together, would generate a different marginal effect for every individual. So how do we evaluate that? So we have similar problem as what we had last in the lecture when we have nonlinear models. So we have individual-specific marginal effect. How do we evaluate that? Well, one simple thing, because it's a linear model, one easy way is we choose a representative individual. What is the representative individual? That would be individual happen to be the age that equal to our sample mean, for example. Then he is a representative. We can regard that as a representative for our sample at least, because he happens to be at the age equal to our sample mean. So we can interpret the marginal effect for an average or representative individual for our sample. So we would assume, can you remember what is the mean value of our sample for the age? We can quickly see that. The average age is about 40. Okay, so our representative individual in this sample is about 40, at the age of 40. So compared with himself, if this person at the age of 40 make a progression to his 41, then what would be the marginal effect of that? But we still have to deal with these two combined effects. So remember, our regression assumes that our y variable, which is the which is the binary choice variable, it has some other variables. I'm going to ignore that. But I just care about one thing, which is the beta times the age plus beta 2 age squared. I have two age terms. So in order to interpret the overall effect of age on our participation decision, then we know that is equivalent to mathematically take the partial derivative